Alright guys, so today we're going to wrap up our organic properties module with carbonyls. And our first carbonyl containing functional group is the carboxylic acid. So carboxylic acids are organic molecules containing a carboxyl group. So that's going to be a carbon double bonded to an oxygen, then single bonded to an OH. And just as a refresher, what does the R mean? That's right, R means rest of the molecule. Okay, so how do we name carboxylic acids? So our parent chain is going to be the longest carbon chain containing a carboxyl group, and numbering is always going to start at the carbonyl carbon. And we're going to name these by taking the alkane name, dropping the E, and replacing it with oic acid. So go ahead and pause this video and see if you can give me an IUPAC name for this molecule on this slide. Okay, let's see what you came up with. So we'll start by numbering our chain, and we're always going to start with the carbonyl carbon. So a 4-carbon alkane would be butane. So we're going to drop the E and replace it with oic acid. So the final IUPAC name for this molecule is butanoic acid. Okay, let's try one that's a little bit harder. So go ahead and pause this video and see if you can come up with a name for this molecule. Okay, let's see what you came up with. So we're going to start by numbering our parent chain, which is going to be the longest chain containing the carbonyl carbon. So a 5-carbon alkane would be pentane. We're going to drop the E and replace it with oic acid. But we have a substituent here. So we have a 3-carbon substituent that's attached at the middle carbon. So a 3-carbon substituent that is attached at the middle is an isopropyl group. And where on our parent chain is the isopropyl group attached? It's attached to carbon number 2. So the final name for this molecule would be 2-isopropyl pentanoic acid. So when we talk about carboxylic acids, we often refer to the alpha carbon, the beta carbon, the gamma carbon, and so on. So in case you didn't know, alpha, beta, gamma, those are the first 3 letters of the Greek alphabet. And when we're talking about carboxylic acids, an alpha carbon is going to be the carbon directly attached to the carbonyl. And then from there, we're just going to go in order of the Greek alphabet. So the next carbon down the chain will be our beta carbon. And the next carbon after that will be the gamma carbon. And that's as much Greek as I need you to know for this class. Alpha, beta, gamma. Alpha is going to be the carbon atom directly attached to the carbonyl. Beta will be the next carbon. Gamma, the next carbon after that. Okay, so looking at this molecule, I want you to pause the video and see if you can identify the alpha, beta, and gamma carbons and tell me which position the hydroxy group is attached to. Okay, let's see what you came up with. So we have our carbonyl, and then the carbon next to the carbonyl carbon will be the alpha carbon, followed by the beta carbon and the gamma carbon. So this molecule is what we would refer to as a beta hydroxy acid. And if you've been keeping up with the health links in the book, you would know what an alpha hydroxy acid is and what they are commonly used for. So I want you to go ahead and answer one more question for me. So go ahead and pause this video and see if you can give me a name for this molecule. Okay, so we'll start by numbering our chain. So a 6-carbon carboxylic acid would be hexanoic acid. And this time we're going to treat the OH as a substituent. So we have a hydroxy substituent at position 3. So this molecule would be 3-hydroxyhexanoic acid. So how did I know to name this molecule with the carboxylic acid as the parent chain instead of the alcohol? Well, the answer to that is it's complex. There's a pecking order for functional groups when you're naming organic molecules. The good news for you is there's only one functional group on the pecking order I want you to know, and that is that carboxylic acids are the most important functional group. So if there is a carboxylic acid present in a molecule, I want you to name the molecule where the carboxylic acid is the parent chain. Okay, so in earlier slides, I told you that when you're naming carboxylic acids, the carbonyl carbon will always be carbon number 1. Well, here's the one exception to that rule. When you have a benzoic acid, that's where you have a benzene ring attached to a COOH, the aromatic carbon attached to the carbonyl will be carbon 1. So this molecule at the top right is benzoic acid. So if I were to number this benzoic acid molecule, the aromatic carbon attached to the carbonyl has to be carbon number 1. And then we're just going to go in order around the ring. Okay, so now that you know how that works, go ahead and pause this video and see if you can come up with a name for this molecule at the bottom left of this slide. Okay, so this is a benzoic acid derivative, so let's go ahead and number our aromatic ring. And we know the carbon attached to the carbonyl has to be carbon 1. And we want to give our ethyl substituent here the lowest number possible. So that means we have to number this ring going counterclockwise. So that means the IUPAC name for this molecule will be 2-ethyl benzoic acid.